What's up? I'm gonna be reacting to Eric Weinstein on Brian Keating's Into the Impossible podcast, titled The Past, Present, and Future of Theoretical Physics. So I thought I'd watch this. I listened to like 10 minutes and decided, I'll just record myself watching it. Maybe, I don't know what they talk about exactly, but I'm sure I'll have something to say.
To our friends. I'll tweet the link and you can rebroadcast it if you so desire.
I even did Instagram Live to promote.
No way. Oh, okay. Awesome.
Yeah.
Awesome. All right. I think we are live. Let me check on the interwebs. Is there anybody out there that can see us? I've got, currently, I don't see it, but we're waiting. Let's see here. 27 thumbs up. There's one person watching it so far. Let's give it a second. Sometimes it takes a little while. We're used to
It's my aunt. She's very disappointed in me.
As well she should be.
As well. She's been a doctor.
Now we got some people. We have some amazing eyeballs on the prize. Welcome, everybody, to this special live stream edition of the Into the Impossible podcast with my friend, my mentor, my advisor, my teacher? I don't know. My rabbi.
It's a way of saying drinking, buddy.
Dr. Eric R. Weinstein. How are you today?
I am well-ish.
Well, I've been better and I've been worse. But I'm better now that you are here. And we have a couple of hundred people already gathered around to watch us converse about the future, the past, and the present of physics, of astronomy, of cosmology, and of even things like this golden piece of gelt that I've been fixated on for a long time. And we're going to get some questions from the audience because they're complaining that that you have not had a update on your YouTube main channel with 250,000 subscribers. People are getting peeved. Let's just say it.
Listen, did I not foresee this and actually post a recent episode of The Portal on my YouTube channel? Brian, you're behind the times, sir.
Oh, okay. It must have been like in the last 20 minutes because I've been checking it hourly.
All right.
So yes, and there's certainly a Portal community, and you should check out Eric's channel, Portal, and you should check out Portal Clips. He has multiple channels. He's gone fully Hollywood, which I salute. And today we're going to talk about a bunch of interviews and a bunch of new topics that I've been getting into as we near the end of the real first season of Into the Impossible, the podcast that I run here from UC San Diego. I've had on many, many guests. None as great as Eric, of course, even despite all the accolades that some of my guests have on.
You've got to be kidding. As the man who's had, who you had recently? Sheldon Glashow appeared?
I had Sheldon Glashow.
Noam Chomsky? You're killing it on the guests, sir.
I'm doing well. I'm trying to bring science communication to the masses, and we're going to have on Frank Wilczek next week. We're going to have on Martin Rees, Lord Martin Rees. I'm going to have
just keep coming.
The Astronomer Royal is coming on my channel to tell me my horoscope, as he does with the Queen herself. All right, so we're going to start off with a conversation between me and Eric, kind of riffing on, we chat frequently. You're very generous with your time and your space time. And we're going to talk about depression, a malady that I had this week, existentially getting to, really, what is this channel about? Why am I doing the podcasting that I'm doing? Why is it merely a service to do for the community, which I love, and I love scientific outreach? And maybe should it be an obligation on scientists to communicate? And I want to harken back to our first conversation way back in April, which you can find on my channel in various places. But that was about the awful, terrible, no good job that physicists do with the best material on Earth, literally on Earth, in the heavens, and we do a terrible job, according to one Dr. Eric Weinstein, with publicizing, popularizing, and monetizing what contributions we've made to humanity. What say you, sir?
I think it's still true. I think that, well, first of all, you have to realize that because I'm not a member of your community, but a member of your viewing public, I very much appreciate physics from the perspective of somebody with a bit of a math background who's been focused on the reason for learning mathematics for some of us is theoretical physics. I do think that we see that the physics community has some of the world's most interesting product, if you want to put it in kind of crass terms, and there's a huge demand for it because everyone wants to know, well, what is this most difficult of fields? What is it telling us about ourselves, the purpose of being, reality itself? And yet there's this translation issue, which I sort of analogize at times to not having an orchestra to perform sheet music for people who desperately want to listen to symphonies. So you keep handing out pages of sheet music and everybody looks at it and says, wow, it's a lot of squiggly black dots and lines. And a tiny number of people say, oh my God, I cried. And you're thinking, I wish I could get there, but I have no idea what you're talking about.
Yeah, I often say, we're accused of preaching to the choir, but you have to do that when the choir forgets the melody, right? You cannot ignore it. And in fact, there's no shortage of controversy in our field. I mean, just this week, this epic brouhaha erupted with none other than our friend, Sabine Hassenfelder, Dr. Sabine Hassenfelder, who you debated live with me over the summer on Theories of Everything special podcast.
Viciously.
It was brutal. And the thriller in South California, I don't know how to say it. But anyway, the point being that she is embroiled with other Titanic intellects, including Lenny Susskind. So she called this paper...
Oh, he's got a little pad to change the scenes. That's nice.
She picked the fight with something. She's fearless. She's like, what, 5'2", and she punches, about above her weight. Let's just say that.
Hang on a second. I have something in my throat. Honey badger. Honey badger.
All right. Well, we can't say that. That is forbidden here at the University of California. We may not refer to
honey
any
badger because she's tenacious and she's very rarely intimidated. That was where I was going.
Yeah, but I want. Okay, so I'm going to be the contrarian today. You're going to be the optimist. You're going to be the Pollyanna. I'm going to be the Cassandra. I think a lot of what's happening in physics has become fashionable to criticize physics, to say nothing good has come out of physics. Everything in physics is overhyped. That was her thing this week. It was, the black hole information loss paradox, which I want to get into because I talked to Lenny about that this week. She calls that the most overhyped aspect or topic in all of science, and she's sick of it. She says that it's total nonsense, you can't test it, it's irrelevant, and it's by no means the biggest, most important thing, whereas Lenny said that he literally, the black hole war that he waged with Stephen Hawking in his book, The Black Hole War, made the world safe for quantum mechanics. And the reason he said this is that he, as you know, I've been having a lot of debates lately with people like Jana Levin, even, not debates, but she's been on my show, I've had on other people, like Lenny, like Sir Roger Penrose. And I said, show me the evidence that a singularity actually exists. I know they're beautiful mathematical objects. I know that they have wonderful, delightful properties. And I said to Lenny, show me an example where you know for certain that singularities exist. And then I'll say, it's a problem that we can't unify gravity with quantum mechanics. And nobody can do that. And even Roger, when you were on, you did a guest appearance on my show with Roger recently, and nobody can come up with a reason that there has to be a singularity whatsoever. So my claim is, do we even need a quantum theory of gravity? Sabina's even saying that's not even as important as, or as unimportant, say, as is this issue of the black hole information loss problem. So just to recap for people that didn't see the video, Lenny claims that the most fundamental law of nature, the so-called negative first law of thermodynamics, is that information is conserved. And he claims, moreover, that the black hole event horizon, or actually, to be technical, this thing called, that he calls a stretched horizon, some people call the firewall, that's even more quantum than the singularity. But getting back to my point, what if I told you there is no singularity, or we'll never know there's a singularity or not, and we don't know if the Big Bang actually was a singularity, or if it's like Sir Roger postulates, or my friend Paul Steinhardt postulates, that's a cyclic universe. There is no need for quantum gravity whatsoever, so shouldn't you get out of the geometric unity business? In other words, why do you think there has to be a unified theory of gravity with, just because Shelley did it with Electra Weak, do we have to even have a reason to think that it's true for gravity plus the other lighter forces?
You have opened up multiple cans of various sizes of nematodes, sir, and I don't even know what to say. Let's just try to figure this out for the public at large and see if we can hide our own ignorance at the same time. I guess what I would first start by saying is that what's on the line here is that Sabina has become sort of the curmudgeon to the world of theoretical physics, where you can sort of reboot in Sabina mode rather than safe mode. And she will keep you from being hoodwinked by the various people who wish to sell you snake oil in the halls of physics. Lenny, on the other hand, is one of the architects of the most dominant and appealing theory, and I would say certainly the largest deep program we have. Whether string theory is right or wrong, let us not make the mistake of being anything less than generous at first. It's an incredibly generative structure that has produced a wealth of beautiful mathematics. It may have nothing to do with the physical world, but it is still richer as a theoretical and intellectual system than anything else that is being bandied about as a potential candidate. So there's a lot on the line when the most prominent curmudgeon...
I mean, yes, as a potential candidate, I'm still waiting to know that anyone's even aware of my model. So is that a potential candidate? Is that included, or is that just not part of that yet? I'd say it's not part of it yet, because, I mean, god damn, guys, it is fucking beautiful. Like he's saying, like, people just aren't seeing it, and a few people are just, like, weeping. Like, here it is. All systems function the same. All systems are the same. All is one. And there's this infinite spectrum, all of which functions the same, though, depending on the observer, which really, like, shows just how alive everything is, and how intricate it is, how unlimited reality is. It's like seeing the light. It is. It's like seeing the light.
Whether you think she should be or shouldn't be, that's up to you. Speaking to the most prominent of claimants to the founders of the top theoretical framework under development. What's this really about? It's really about the fact that we're stalled. We should be working on new ideas. We can't quite figure out what to do. So everyone has figured out, in some sense, what he or she is capable of pushing as a series of pawns across the chessboard. Sabina can easily say there's no testable consequences. It's angels on the heads of pins. Why do we even need a unified theory? Maybe it's not unified. Maybe it's not beautiful. Maybe. And Lenny can say, wait a second. That's a lot of emptiness.
It's kind of like God. It's like, why do we need God? Well, it's not about what we need. It's just what is. God is. And why do we need a unified theory? It's just what is. Really. I mean, it is. It's not about a need anymore if it's just what is. And why do we need to unify? It just is what it is. And does it need to be beautiful? It is beautiful. Does it need to be? Doesn't really matter, because it just is that way.
We at least have done some stuff in string theory. We predicted gravity, technically post-predicted it because we knew it was there. Then he's going to say something about black holes. Now, I think it's really important to sort of get kind of the culture of you guys. Again, I'm not stepping into this physics ring, but in a weird way, the quintessential example of a physical system, if you had to learn one simple physical system and milk it repeatedly.
Uh-oh.
You say it's a weight on a spring?
Mm-hmm. Yep.
I can't hear you.
Oh
no.
Oh, no.
We lost audio contact with Dr. Brian. Ground control to Brian Keating. Brian, I cannot hear you, sir. Oh, no.
There we go. How about now?
I'm not panicking.
You hear me
Replace
now?
your aids. The audio's gone out.
You hear me now? You don't hear me.
2 words.
I hear you. You don't hear me. That's weird.
Dark.
Now you don't hear anything.
Never.
All right, let's try
Can you hear me,
another.
Brian?
I do hear you.
You can hear me?
You hear me?
Okay.
Okay.
So maybe I'll keep talking, and then you keep saying stuff in case they reestablish the audio. I can always
I think
try back.
people hear me. Can someone out there say that they...
Brian, I'm going to open find me on it. Start sending me chats.
I hear you.
Yeah.
Eric, let's see. You don't hear me. Let me hold on one second here.
We apologize. Brian, I wonder if I should hang up. You should keep the stream open, and I should try to log back in
Yeah,
and see if
I
that solves
just
our
changed
problem.
something. Let's try that, because I don't know if people can hear me out there. Yeah, go for that. Do that.
Okay.
Yeah, do that. I believe you can still hear me. Let me see.
Find me on it. Start sending me chats.
I hear you, and people hear him. So I'm going to try to get Eric back on the line here. Everybody hears both of us, so good. Okay.
Apologize.
I hear you. And let me try to get Eric back on. Hold on one second. I'm going to get him back on. Please pardon the interruption, but we're getting more and more people in the chat room, which is good. I tried to switch to a different headset. Now, Eric.
Doctor, can you hear me?
Yes, I hear you. Do you hear me?
All right, I'm going to try. Can you see me?
Now I see you. Do you hear me?
Yep.
All right, great. So you were saying about Sabina as playing this role of Cassandra, so to speak, but I'm kind of decrying it, that's become the fashionable way to go about things.
Yeah, and I love the fact that you're giving me an opportunity to be more optimistic by pointing out too much pessimism, right? And so I appreciate the opportunity. I don't usually get a chance to do this. A lot has actually happened in the period that I would say is generally stagnant. And one of the things that's happened is that the foundations of the mathematics underneath theoretical physics has gotten shorn up at an incredible level. One of the reasons I think that we think that this is going to be more unified is that we find certain motifs permeating every layer of the physics stack. In particular, I would say differential geometric bundle theory, whether it's the tangent bundle of space-time, which is kind of the default bundle that comes with the arena in which physics occurs, whether it's this crazy new bundle called SU3 cross SU2 cross U1, which handles the non-gravitational forces, or whether it's what we would call pre-quantum or quantum line bundles that live on top of these structures, which give us the quantization of.
You can't explain gravity with other forces because it's simpler, because it only pulls. It doesn't also do other things. And so to explain it with other forces is impossible because it's the simplest force. It's not that that it exists because it's emergent, but it's more fundamental than, say, magnetism, because gravity causes electromagnetic fields by the infinite structure of the universe. So a little detail, there's larger and larger particles and smaller infinitely, and those particles are capable of passing through one another if they're the right relative masses. So like neutrinos can pass through the earth, and because of that capacity of particles to pass through other particles, if there's a particle stuck in the gravity of another particle, where the first particle is much smaller, say infinitesimal relative to the other one, then it can be pulled directly towards the other body. But then because it passes through it unabated, it continues on, it goes out the other side, and gravity is in the opposite direction. And so it comes back and creates a figure 8 orbital. And so gravity creates electromagnetic fields. In other words, it's more fundamental. So we can't explain that which only is a pull with that which is both a push and a pull, because the push of magnetic fields, it comes from the fact that the figure 8 orbital has a portion out and an in, out, in, out, in, out, in. And so it, by gravity alone, produces this like 2 feature positive negative positive negative. And so but gravity is also emergent. It's not like it's like a body has gravity, in that it's not like just pulling on things, rather it's blocking flows of particles. So there's infinitesimal particles so small that they would make the particles that make up light look like they're galaxies relative to these smaller particles. And then even smaller particles that would make those ones look like galaxies relative to those particles. So small that essentially they move at an infinite velocity for our perception, causing an instantaneous effect, which is gravity. And so what happens, though, is when there's 2 bodies near each other, they block a portion of the flow towards the other object and create basically a low pressure region between them, and so they attract. It's not that they are exerting gravity, it's that they're blocking ethereal particles and causing a low pressure between nearby objects that causes then the observation of attraction. But that's all from the infinite nature of reality. And because those are like galaxies. For another observer, those particles we see as photons are galaxies. And so like within the tiniest of space is a universe as larger to an observer than what our observable universe is. And within a larger space, all that we see is just a tiny space in that observer's reality. And it goes on forever, and making it possible that there's dimensions of reality going on forever within and without. Which again, it's beautiful. It's crazy. There's dimensions on that scale where they're within and without.
Of those classical theories. One of the things that's happened is that we've gotten almost all
classical theories. What I'm saying is purely classical mechanics. Just here's the thing: is infinity, and particles can pass through other particles. Not necessarily, but they can.
I would say all of theoretical physics at its most foundational level now appears to be differential geometric and differential topological. Now, there's a huge question. It's one of the reasons why I thought that Lenny was in some sense evasive when you tried to ask him about the singularity. It was kind of an interesting evasion, to be honest about it. But what he said is it doesn't really matter because we don't see the singularity. The singularity in the black hole is screened. So what we should really be looking at is the last thing that we can probe experimentally, which might be the event horizon or the outside of a disk. Who knows? And then the point is now I don't even have to worry about the breakdown of the laws of physics and the challenge to Einstein that's happening inside that. Because if the only things I can test are outside, then even if physics is happening on the other side of the event horizon, what's it to me? And then you can also go further and say, look, maybe the classical stuff that Einstein was up to and all of this bundle theoretic stuff of Simons and Yang, you had Jim Simons on your program, you absolutely have to get C and Yang. And when I get you on Rogan, you cannot eat in front of him because he's got misophonia, I think, and he's very susceptible to sounds.
No one can see me eating but you.
But I digress. I think that, in essence, Lenny is, he's equivocating. He doesn't know what's going on the other side of that thing. And what I take is I'm processing it for meaning. I think that space-time isn't a crutch to get you to your quantum theory. It's not, there's this very fashionable position, which is we shouldn't be quantizing classical theories. We should be taking the classical limit of quantum theories. Therefore, your attachment to this quaint religion of manifolds and bundles and all of the stuff that makes us feel good as geometers, this is just an intermediate way of getting to the ultimate truth, which has to do with correlation functions and quantum measurements. Now, I think that's kind of ridiculous. Even if you take the classical theory to be effective, it is so astounding in its completeness as a description for the substrate of a quantum theory in the standard model that I think it really raises the question, maybe this bundle structure is pretty close to being right, and that maybe Einstein's a little bit wrong. And boy, if Einstein were a little bit wrong, wouldn't that be great? Because a lot of the no-go theorems, think of him as your unfun parent who won't let you do all the things that you want to do. In some ways, you're not going faster than the speed of light, no matter how fast you think that the Ferrari should go. It's capped out. So I think it's really important.
Which is disproven by the fact that gravity is instantaneous. I mean, period. Disproven. Something's faster than the speed of light. Just because we don't know that it's particles moving faster than light, it's still faster than light.
Important to realize that one of our best hopes for Einstein being wrong is the idea that a true theory, in a certain sense, and I'm going to say something that makes Sabina crazy, but it doesn't mean what it sounds like, shouldn't have these singularities. The singularities, you said that they were beautiful. I thought that was interesting because I find them to be repugnant.
Yeah, I mean, certainly they are. And again, I don't think I've asked you this, but I've asked a lot of guests, including Lenny and including Sir Roger.
Shouldn't have the singularity. I mean, that's an interesting thing. Because the singularity in reality is essentially all is one. That's the singularity. That seems pretty legit to be, that's like the center point where everything resonates from. Fucking nothing. I'm just thinking about nothing. Like, what about nothing? As simple as possible, but never simpler. There might be some truth to that when it comes to nothing.
And I also want to get to the point of what do you do when you're talking to somebody, and you've talked to people outside of science, so none of the people I talk to in science are BS artists, but you talk to, besides me, you do talk to people that are sometimes accused of BS. What do you do when you're talking to somebody and you know they're wrong? Like, you know that they're not intentionally obfuscating, they're not mendacious, but they're just wrong. And how do you handle that as a host? I mean, it's and I'm not, by any means, I'm not comparing myself to any of my guests. I view myself as a simple, as I said, I'd call myself a simple plumber, except for the fact that Lenny Susskind was a plumber and Shelley Glashow was.
Does that include me? People think that way. He might even be thinking about me as one of it, and as an example, because I'm pretty sure he's seen my work, because he's responded occasionally. Maybe at least clicked.
Was a plumber, and actually Lenny worked for Shelley's father, who still has a fleet of plumbing trucks in New York City. But anyway, I digress. I'm a simple experimentalist. I build things, I tinker with things.
Have you looked at my work, Brian?
But actually, I'm going to defend experimentalists later. But I'm not saying I'm brighter than these people. But I know in the case of Sir Roger that he's made some mistakes, and I think those mistakes attest to a confirmation bias that he has that I pointed out. And I'm not talking behind his back. Lenny is, I don't know him as well, but there are times when I was like, I'm not sure. If Sabina were here, if she.
Damn, I'm talking behind his back. Sorry, Brian. What's interesting is I have an actual experiment that I think would be worth testing that I've pointed out to them. To Brian, to Eric, anyone I'm trying to reach out to. I'm also like, by the way, here's this really simple experiment, which is essentially just like changing the materials of a single slit experiment and seeing how it influences the wave. Seems pretty simple. I mean, maybe it doesn't have any effect, and that would be pretty detrimental to my model. But I'd imagine it would be observable if it only makes sense. So I'm like willing to like put my neck out and say, let's fucking test this. Which is interesting, you know. If it showed results where there was a correlation between the wave and the mass of the material that was especially able to be shown to be a function of the law of gravity, meaning gravity is causing the observation, that would be something. That would be something. That would be game changing. worth the looking into. Worth looking into. Just throwing that out there.
You would agree with that. I'm not saying I agree with her either. Go ahead.
Give me an example.
So Roger talks about the BICEP2 data that I played a big part in producing the BICEP experiment, that manifests evidence for Hawking points, for the persistence of memory of black holes that survive through the catastrophic end of the heat death of a previous aeon, going through to a new eon. And he claims there's evidence for this in the Planck data, in the BICEP2 data, and so forth. There's been proven, I think, pretty conclusively that neither one is true. And in fact, in one case, Eric, what he did was, if the Fourier transform of an image, or the image itself, contains a lot of information, but none as much as the hologram of an image, from which you can construct phase and amplitude information. What he did is try to extract phase information from a photograph, which is fundamentally impossible. And I knew that, and I pointed it out to him, and he's still talking about it. And by the way, the paper that I live streamed with him 2 weeks ago about, and he's so super gracious, I love him to death, but that paper was held up in publication up until he won a certain golden gilded piece of gelt. And the question is, does that influence things? I don't think it should.
All right, well, I'm going to make a really crazy argument, which is irresponsible and will probably get me thrown off of your channel. But here goes, because we were just playing, right?
Yeah, that's right.
Maybe part of the problem goes back to Dirac's observation on Schrodinger. And his point was that Schrodinger delayed publication because there was a failure to fit with experiment. And his claim was that we push this on people. Your theory, when it's found wanting, you should capitulate. And Dirac said no. There was a small issue of spin which caused the data not to conform to the theory and its predictions, and Schrodinger was unduly intimidated by this. And so I think what I want to talk about is cheating and theft in the life of a theorist versus the life of an experimentalist.
Yeah, let's go there.
All right, so here's the really crazy idea that will immediately get me laughed out of your channel. The problem is every good idea is dead on arrival.
Care to elaborate?
Sure. We have a machine in physics for producing good ideas. If something is commutative, we say maybe it's non-commutative. If something is symmetric, we say maybe it's supersymmetric. Maybe the symmetry is broken. Are there 4 dimensions? I think there are more than 4 dimensions. What if there were fewer than 4 dimensions? We keep varying each parameter. It's very similar actually to what the neoclassical economists do. They have the concept of a perfect market, and then they relax the hypotheses, and they say, if this failed, what would be the consequence? So in a weird way, you hold up this idealized thing, which is the perfect market, and then you violate the hell out of it all the time because that's what produces research. Well, where we are in physics is that physics can't move. The straitjacket has gotten so tight that Houdini can't dislocate his wrist to get out of it. And so if you start piling on all of the experimental indications, all of the no-go theorems, all of the instances where some brilliant person tried for 10 years and failed to make progress on a particular area, we've been failing for so long because we succeeded many years ago so well that it now appears that we can't get to the end. We can't figure out what this is all about, in part because every imaginative idea dies instantly when it gets checked against something in the mind.
In the mind or in the marketplace of ideas and data? I think there's a big difference.
Well, so this is this thing. I brought a guitar, and the point that I was going to make is that
you're not a string theorist.
So I want to point out he's saying there was all this progress and now we're just kind of stuck, and that's because we're hitting too much resistance through this like method of analysis. Like it doesn't take us to the end point because essentially it's limited. Without an infinite model, without a true path through to actually reach understanding, like get there, which is an infinite route, like we're gonna get stuck, and then we're just gonna be pushing against that wall, which chipping away at it, but like until we turn around and like go back onto the right path, the one with the least resistance, and make it through all the way to the end, then we're just gonna be stuck. And he's saying dead on arrival, and then that's true. And Brian is saying, trying to defend it almost like, hey, there's some merit to them being dead on arrival, but not always. That's the problem, is sometimes too much gets filtered because people, like he's saying, it's our belief systems. When they clash, when something's counter to our belief system, and there's like, especially in science, when there's so many people in agreement on the standard narrative of science, whatever is mainstream, that, the mainstream it's powerful. It's got a lot of people who agree, and so it's easy to be in agreement and then look around and be like, well, I have all this backing. That's not just me, but all these people who are in agreement. So I don't even need to necessarily know completely why it's true, because there's so much backing that we all agree. And but it's just wrong. The models are wrong. That's the problem. They're not even approximations. When you really get down to it, they're just wrong. And it's just Newtonian. Which is simple, we learn it in high school. We don't learn it in college when when it is an approximation, and one that really barely fits. Next to infinity, it fits zero, meaning it isn't even an approximation. It's just enough of one, that we can kind of push our boundaries a little bit, but it's chipping away. It's not really getting us to an understanding. We're just kind of happening to see things, putting those things into use, thinking that our interpretations of those things are correct because we've managed to apply them in some way, and then reinforcing that our beliefs of how we think the things function are true, creating this a loop where it's just absolute certainty, but then it's like a rod. If it's not flexible and it starts to get bent, at some point it's just gonna snap, without the malleability. And that's what's gonna happen, because it's just not true. It's just false, the current models. And there's 3 models claiming the position of a single model, basically allowing the other 2 to coexist with them, and therefore all basically agreeing and colluding to be part of reality. Oh, okay, you can have that sector. So these 3 models are good because we've got things covered through all 3 of them. But then it's just not a model. So, honestly, I'd say anyone who claims to have a theory of everything, regardless of the accuracy of it, has a more valid model than the current science. Because it's literally 3 models. And so it's just not even equivalent to any model that's just one. Even if it's wrong, at least it's on the trail that it's a single model and not 3 models. They've made that first step 1 model. We can't be step 1. Okay, there's probably as many models as we need. Whatever the fuck we need to explain as much as possible. Because we got it. Oh my god, it's crazy. And then it's ego. Oh, I understand the thing. Aren't I brilliant? Look, I'm a fucking idiot, and I understand the thing. So, the truth is, it don't take some intelligent
If I pluck the string, holding my finger exactly over the halfway point, I get a sound that vibrates at twice the frequency. That's supposed to be almost exact. If I play the harmonic that divides the string in thirds, that sounds like a perfect Pythagorean fifth. But it's not the same thing as what we would call the even-tempered fifth. Your piano will produce a different notion of the note G than you would get if you played that trick with the string. It's off by a tiny fraction. In fact, you cannot square. And even temperament intervals are like quantum mechanics and gravity. They don't yet fit together. And in fact, in that case, we can prove that they can't be fit together. So my point is, you could then say, okay, so that fifth is not really the perfect fifth, so then we shouldn't make musical instruments that are even tempered, and then nothing will happen. Well, it turns out that that's a really bad thing to do. Your piano works fine, and your ear will compensate for a certain amount of problem, and no one will ever solve it because you can prove mathematically it can't be solved. That means that we get to play the piano rather than just immediately packing up and say, oh my gosh, unfortunately your theory has faster than light communication. Unfortunately, your theory is inconsistent with observational data from the survey of the galaxies. We can see blah, blah, blah. It's important to get enough space to be imaginative. And I sort of think that in part the theorists have to steal from the till in order to do some business to put more money back into the till by the end of the day.
Sorry, Eric, your mic's breaking up a little bit. Yeah, I don't know if you're on it, but I actually brought this up.
It's a good point. I really think there might be something in all of the, even though I'm calling them approximations, there might be something to them if they take into account the infinite classical model, where maybe it brings to light something else so we can kind of like make sense of those observations and like dig into like the fractal quantum nature, maybe, and thereby like feed energy into it, because we're kind of like redlined, we're at that wall.
Up to Lenny, and I said, part of the reason you're so successful is because you're not on social media. But in reality, there's some truth to that.
I was listening to Cosmographia, Randall Carlson's podcast, and he's talking about Atlantis. I'm almost done the Atlantis series, and they're talking about shattered cone and how it's almost like a single point branches off, like there's like something that comes in, hits a point, and then it branches off and into many different branches. I'd like to like have this information come in and hit and then branch off through all these sciences and just everything, through every boom, just like impact.
He hates social media. He feels like it's ultimately a very pernicious entity. And the reason I'm bringing it up is because I had a conversation with Paul Steinhardt more than 2 years ago, maybe, and he was talking about, and he's very creative. He can think outside the box, and he's a member of the orthodoxy of physics at the highest levels, the Einstein professor of physics. There's that name again at Princeton. Can you hear me?
Can hear you.
I think it's it might be your sound system. I'm hearing you. I think people are mixing the audio. Can you say something? It's not coming through again.
Are you sure you can't hear me?
I hear you now. I hear you.
Okay.
You hear me, okay. But the point is that you might come up with an idea, and then someone takes a picture of it at a conference and then tweets it around the world, and you get ridiculed. So these things become, stillborn, so to speak. Is that what you're talking about? Or are you talking about, like, actually, I show you this plot of data, and I say, you abuse the data. Dude, you violated the constraints that this data have imposed upon them. Like, for example, we make maps of the microwave sky. We're not seeing it in real time. We have a lot of filtration. We have to get rid of the ground. We have to get rid of time diurnal effects, calibration effects. Those are very hard things to evade, as hard as evading, Lorentz invariance. So I wonder exactly what you mean. Do you mean that, like, these things shouldn't be subject to the same constraints that, say, data analysis would put upon them?
Well, think about it in terms of our history. There used to be something called the tau theta puzzle that had to do with weak interactions and beta decay. And the tau theta puzzle sort of created a paradox, but it assumed that the universe was symmetric in a mirror. And the solution to the tau theta puzzle involved, what if the universe actually had a beauty mark, like Marilyn Monroe or Cindy Crawford, so that you could tell, right? So I have a few moles on my face. You can tell whether it's
yeah.
So, but I thought people would rather think about Cindy Crawford.
Yeah, that's true, yeah. Marilyn Monroe. Than either one of us.
So the situation there was that it was very painful to propose the idea that maybe the weak force, different from all other forces, would decide that it would break this kind of mirror reflection symmetry. And who knows why? I mean, it's one of the most astounding discoveries in the history of physics that that's true. But Feynman gave a description of being at a conference or something in which some lower ranked person said, why are you guys so keen on the idea that the universe has to be left, right, symmetric? And Feynman said, I'm asking this question for so-and-so. Everyone claimed that he was doing that to humiliate the guy because he wasn't strong enough to do it himself. Feynman says, no, he would have been able to. But this gets back to the issue of disagreeability. Now, disagreeability is one of the things that leads people to being called a-holes in science because you don't go around along with the crowd. I've interacted with Lenny before. He's not an a-hole, but he's grumpy. He's highly disagreeable. He's got the strength to say things that other people wouldn't say.
You know what's amazing about that? Before you go on, I asked him, I asked Shelley, and I asked Barry.
I'm kind of an asshole. I'd say short-fused. At wit's end. Maybe that's what's going on.
Barish. I said, what thing did you not know, when you were 20, that because you had courage to go into the impossible, as is the name of this podcast, now you believe to be thoroughly, eminently feasible, but only because you had the courage to go a little bit into the impossible.
Sure.
And 2 of the 3 of them said it was overcoming imposter syndrome. That basically, so 2, that means one of them was a Nobel Prize winner. Can you guess the one that didn't say he suffered from imposter syndrome?
And what is my group?
The group is Lenny, Barry Barish, and Shelley Glashow.
I'm going to guess that Shelley does suffer from it. He did suffer from it. And I don't know Barry Barish.
It was actually Barry and Lenny.
Okay.
Barry said, and this gave me chills. It gives me chills to talk about it right now. He said when he accepted his Nobel diploma in Stockholm, he was asked to sign a book. And in that book, when he received this medal, he said he wasn't intimidated by this. He was intimidated by this. He saw Einstein's name.
Yeah.
He panicked. And I haven't released the interview, but it was one of the most deep interviews I've ever done. And it's just so touching that this guy's a Nobel laureate, and he could talk for hours. And Lenny is like that too. When Lenny got over imposter syndrome, he was 50, he said. Full professor at Stanford University, Feshbach professor, I think he is, National Academy member. He says it wasn't easy. And that disagreeability, which I think you have a confidence, you have a swagger, and I think that has served you, but also I think it pays to have a little bit of insecurity.
All is one. There ain't no imposters.
I have a question from one of my listeners.
If anyone does ever feel that way in regard to my research.
Who wants to, I think it's harkening to your interview with Lex Friedman. I want to get to it because he paid $15 to ask this question. Thank you guys so much out there. It goes into my Nobel Gelt collection fund. So this is Elon.
Wait, how much did he pay for this?
What's that?
How much did he pay for this?
He paid $15 for it. And then
I'll answer it for $8.
Oh, no, you can't do it. Now we can't do it. Okay, so fine.
No, it's a Jewish joke. Anyway, keep going.
When he says,
You're trying to undercut the marketplace? Elon Tusk is asking, Eric, when you say it's time we got off this planet, please explain to us, which I think you did with Lex Friedman, please explain to us what this looks like if my less successful cousin Elon Musk were to implement this technology, assuming it's possible, to his ship. So in other words, what does it look like to get off this planet? I guess he's not asking the question I would ask. Elon, you should have asked this question. Why is Eric concerned with getting off this planet? But he just asked you the technical question. Sorry, Eric, can't hear you. Give me a response in the chat room. Can you hear me in the chat room? I don't hear Eric. I have not changed anything. Does anyone hear me? Please type in the chat room if you hear me. And, Elon is a Jew as well. Interesting. I don't know. Nobody's perfect. Just kidding. So, Eric, you hear me? I don't hear you. Does anyone in the chat room hear Brian? Please let me know. Elon's technology took us offline. All right, it looks like he's coming back. You don't hear Eric, but you hear me. So I will now play my guitar. No, I can't play anything. The only instrument I play is the iPhone, and I don't even play that very well. All right, let me call Eric back. Yes, you guys are all saying, I'm going to tell this to Eric. I'm going to tell Eric, Eric, are you there? Can you hear me? Eric, active now. He has to invest some of Elon Tusk's money into a microphone. Eric, can you hear me?
I can hear you.
Okay, now I can hear you. Okay, so Elon is giving us this money, and I want you to use it to get yourself a quality microphone.
I hear you.
And this is good. Okay, everyone in the chat room, tell me if you can hear Eric now. You guys all hear me? Okay, good. It's when you guys talk at the same time, Eric falls off. Anyway.
So now I've changed my microphone and my camera, and people are going to be angry because my Dell computer is going to be looking up my nose. You're going to see that comment a lot.
I've only heard that. The only thing I've heard more than that is, when is Eric going to publish his theory of geometric unity? That is verboten. We're not talking about that today, folks.
Okay.
All right, how do we get off this planet? Just how, not why. How?
Well, I think part of it would have to do with using degrees of freedom that, if there is a way, if there is any, first, there's like a lot of ifs, so just assume that we go through the boilerplate. Assume that the theory was right, assume that in some sense 14 dimensions somewhat replaces 4 dimensions. We have now 10 extra dimensions. It might be that you'd be able to travel along those 10 extra dimensions rather than along the 4. It might be then much more economical, let's say, to come up to move along the 10 dimensions, then move along the 4 where it's easier, and then to go back up the 10 and now you're somehow farther apart. I don't even know whether that's a sensible thing, but the key thing is we're a bunch of co-traveling waves, and in my estimation, we think we're co-traveling waves in 4 dimensions, but we're actually co-traveling waves in a larger space. And that larger space includes the rulers and protractors of Einstein's space-time metric. And so if those are actually legitimate degrees of freedom, try to imagine, like, you could, at least theoretically, you could imagine if I shrink all of the distances by expanding the rulers, then suddenly, my first operation might be expand the rulers and then move in that new world where, a mile is now an inch, and then contract the rulers. So that would be the kind of, by incorporating the space-time metric as one of the degrees of freedom on which waves can propagate, there might be something to do like that. But the key point is you need to know what the full source code is before you know what you can and cannot do. If we have our current picture as a bunch of effective theories, you might have no-go theorems in the effective theory that aren't no-go theorems in the ultimate theory. And so the question is, does the ultimate theory inherit the same set of restrictions as we currently have in our partial theories known as general relativity and the standard model? I hope that was worth your $15.
All right, well, now we have a bidding war
question.
because someone is asking a $20 question. See, it's very profitable. This is why I do these super chats. Okay, this is from a man who has a name
I
that
promise not to sing for 50.
Well, I was saying, you asked me if I could play someone's asking me if I can play an instrument. I said, yes, I play the iPhone, but not very well. A super chat from a man or woman by the name of R. Maybe it's the software, R. Anyway, 2 questions. So she wants 2 questions. What is the role of category theory in physics? And what do you think about teaching advanced mathematics using computers? For example, use Mathematica. We're going to get to our conversation with Stephen Wolfram not too long from now. And Sage Math, I'm not familiar with that, to teach advanced differential geometry. So 2 questions. Category theory, I guess, should we teach it at an early age when we teach calculus? And then also, what's the role of computers in the teaching pedagogy of mathematics? Thank you, R.
So first of all, for those who are not familiar with category theory sort of got forced almost on the mathematics community because you would notice that certain patterns were highly conserved. So something that seems to be about algebra and like the algebra of symmetries might also be true for spaces and geometric objects. And so you would notice that certain relationships in very different sounding places were carried over. Categories of things are in fact related to each other through things called functors, which are sort of like maps of theories to other theories. In essence, we do category theory for 2 reasons. One, we do it to clean things up and to get to the heart and elucidate what's really going on at the purest level, not to be distracted by the instantiations, which may appear different, but it's the same thing in different guise, same sort of underlying. It's sort of a way of dealing with Platonic truths rather than examples of truths. The other reason we often do it is to avoid work. We don't know what to do, so we say, okay, well, how does that work category theoretically? Maybe we should use 2 categories or 3 categories. You make things more and more abstract to avoid a reckoning. And so there's a good reason to do category theory, which is usually not essential, but it's very helpful if you know how to do it. And then there's this other thing that we do, which is that we sort of go into, mathematicians have this phrase that they call it abstract nonsense, sometimes affectionately, sometimes in a derisive way. How does it relate to physics? Well, what we have, a good example of this would be quantum field theory. In a weird way, quantum field theory takes initial states and asks about the transition to final states. But we have another geometric theory called Bordism theory, where you have an incoming manifold and an outgoing manifold that look like incoming and outgoing states. And then in the 1980s and early 90s, we sort of found out that these 2 things were the same. And that kind of category theoretic version of some sort of equivalence, where something quantum field theoretic and something differential topological were actually the same underlying thing. So I think that there's lots of things that category theory can do if you happen to have a very nice formulation of a theory that makes sense as rich mathematics. I also think that it's a way of avoiding our more fundamental problems in the subject. So I hope some of you will not listen to me and will show me that category theory actually brings the logic.
Now, I should point out that you and I have formed a partnership, a supergroup, which also will involve a certain young Weinstein, not young Einstein, but a young Weinstein, and that we are working on the second part of R's question, which is about teaching pedagogy of mathematics. Does the computer enhance it? And I don't know about Sage Math, but we had a live debate this summer with Stephen Wolfram. I'll put that in the chat room right now, but just so people can refer to it. By the way, if everyone's out there sitting down, your fingers are getting numb and at risk. This is my advertisement now, okay, Eric? Now we're going to make some real money. Your fingers can get carpal tunnel syndrome unless they're exercised. So please take your finger, stick it on the subscribe button to this channel, and that will do me a big favor because we want to get more attention for live streams just like this and the one that we did this summer. What's that?
Love the hustle.
Gotta hustle. Gotta hustle. Okay, so what do you think about teaching young Zev and others mathematics by using Mathematica, for example, by our friend and compatriot in all things theoretical of theories of everything, Mr. Dr. Stephen Wolfram?
I think it's great, but you have to know what some of the problems with it are. So one thing I would say, for example, is that let's imagine that you have a matrix, a matrix with 2 rows and 3 columns. Sometimes in the computer, it makes a difference as to whether it's if it's 3 rows of 2 columns or if it's 2 columns of 3 rows, in some weird way that's irrelevant to the mathematics but makes sense as to how the memory is allocated inside of the computer. So I think it's very important to make sure that whatever you're doing in a pedagogical fashion using the technology you keep track of the ways in which the technology actually fails to mirror reality. For example, in the original formulation of Python, there was a problem with the ring of integers where the brilliant founder of Python, Guido van Rossum, had an idea that the product of two integers is an integer, so that if you divide one number by another, you should stay in the same class. But if you divide 7 by 3, that's not an integer. And so he cast it to the nearest integer. That was an example of something where you thought you understood what you were doing inside of the computer. I'm dividing 7 by 3, but you might find out that you're going to get either the number 2 or the number 3 unexpectedly. So you have to keep track of what it is that the computer is actually doing versus what did you think it was doing. But I think it's a great, Sage Maxima, Wolfram's mathematical project. I would also point to our friends in Austin, Continuum Research with the Anaconda release of Scientific Python. All of these are very helpful tools, but don't, just know where the map between the real math and computer's representation of it breaks down.
Okay, we have another friend, this time across the pond, I presume. Walter Bishop chipping in with a 5-pound note. Question for Brian and Eric. Up to what point do you agree with string theorists before the disagreement branches out? So I want to say before I ask that question, I asked Shelley Glashow this week, author of this really wonderful book that I want, this copy is for Zev when he comes down to visit. I want to know, he has a scorecard, he has a rubric, and I'm going to go through it with you to ask what in the 32 years since this book was written, it's a wonderful book, it's actually probably the best book on the pedagogy of elementary particle physics of unification. And we went through, in this video I'll post probably next week, and reminder, I'm going to have people on, I'm trying to get Gerard Hooft, I hope I'm saying that right, I'm hoping to get the big dog. I'm hoping, yeah, I think it is. I'm going to try to get Ed Witten, speaking of string theorists, Walter Bishop. I'm going to try, but I'm going to need a lot of help out there because he doesn't do podcasts, or so he says. Anyway.
He did one.
What's that?
Ed Witten did one.
He did one, yes, he did one. You have to rub that in. Thanks, Eric. And you're the only EW who comes on the podcast. So why are there some...
I'll race you to Ed Witten. I'd love to.
Now, you never read this book, but you actually resonate very well with it. So here's the first thing that you and I ever talked about. Why are there so many basic particles? Why are there so many free parameters? Why does the number 3 play such a big role in elementary particles?
Why are there so many basic particles? Great question. Maybe because we're differentiating rather than having a unified model that shows how all of them function the same way, and therefore none of them are really significant. The fundamental particle. Did you see the new fundamental particle? They found another fundamental particle. They think there's another fundamental particle, though. Did you hear about the fundamental particle?
And how many families are there all told? So he asked these questions, presuming he'd find out answers, before the year 2000, let alone the year 2020. Hopefully, may it be gone and forgotten soon. Although I'm hoping it's been 5780. That was the problem. Now we're in 5781. Things are smooth. Anyway. What do you make of this, that we haven't made progress since this book was written, and not for lack of spending money? And then I'm going to give you something really... I'm going to say it's a good thing that the SSC was canceled. But for now, please answer this question. What grade would you give these 3 different problems? Why are there so many particles? Why are there so many free parameters? Why does the number 3 come in? What grades would you give to theoretical particle physics?
Well, it depends what you mean. So let's do the first one.
Why are there so many free parameters? Yeah, that's how you fit a model. That's an approximation. You just throw another variable in there until it has enough variables that you fit the curve, and then boom, you got the model.
Why are there so many particles?
Yes.
I would say that he's saying that the number 3 matters because there's 3 collections of 16 particles with sort of 4 space-time states apiece. So all of that is coming from, trying to figure out how to say this to a partially lay audience, but in essence, we have these 4 gadgets called Lie groups. Never mind, they're collections of symmetry. The full name of it would be SL2C cross SU3 cross SU2 cross U1. And then you have to specify a particle by giving some idea of what those groups of symmetries symmetrize in the form of something called a vector space. Now, it turns out that partially due to Shelley, there's a hidden kind of agenda almost in this, maybe, which is that Shelley was one of the first people to talk about so-called grand unified theories. Now, because we have to make everything difficult for the guests like me in theoretical physics, you'd think grand unified was more unified than unified, but it's less unified. It's only 3 out of 4 forces. So we do that to throw off the Russians in case they're going to invade or something like that. We don't know. So you have this weird thing, which is that Shelley figured out a model called SU5, which reduced the numbers of particles, in essence. The space stayed 16-dimensional, but it really broke up as 1 plus 5 plus 10. And then there was another theory called SO10, which again should have been called spin 10, but the physicists have the wrong name. I don't know why they do that to me. And what they do is they put everything in one 16-dimensional symmetric situation. So the number of particles goes down in a certain sense, but the space of the particle expands. If you believe in so-called SO10, which is really spin 10 theory, and there's a different version of this called Petit Salam. You can grade me to see whether I'm a good tourist here. That theory is very similar to the SO10 theory, but it's slightly different. It makes use of something called spin 6 cross spin 4, otherwise known as SU4 cross SU2 cross SU2. Never mind. That theory, both of those indicate that there's a lot more unification. We just haven't seen that it's true yet. So I think that the idea is that we actually have a speculation that there are fewer particles in a certain sense once you heat things up to see the hidden symmetry, and that they're just fewer numbers of more capacious particles in a certain technical sense. Mm-hmm. The number 3 is mysterious because of the number of...
Infinite, all function the same, though, depending on the observer. If we're made of particles and we're observing a relative particle, then it's dependent on the particles we're using to observe it. So our atoms, relative to what we're observing. So if there's an observer composed of some other particle, they're going to look at everything around them using those particles, not atoms. And so the relative mass ratio of the observer to the observed is going to change. And so, like, what was once seen as a star could be seen as an atom. What was once seen as a black hole could be seen as a planet, and so on. And vice versa. All the same, yet all different. Because if you place an observer, then the infinite array comes about. That's when then there's like this upper limit that everything we see is black holes. Even though they're not black holes, they're just more radiant than stars, and in that they emit higher energy beyond visible light. There comes a point where systems are so massive that their emissions for a relative observer, so we're made of atoms, so then we look around, larger objects, some of them, like planets, only emit infrared, and then other ones that are larger, more massive, they emit visible light. And those ones, we call them stars, because that's how we see them. The ones that emit in the infrared, like say Jupiter, that's a failed star, because that's how we see it. Earth, it's just a planet, because that's how we see it. Black holes, well, that's not a star, because it doesn't emit in the visible light spectrum. It emits in the X-ray spectrum. So when we look at a black hole in the X-ray spectrum, we see a photosphere, and we just think it's like the gas surrounding the object, because we think that black holes are singularities, the way we interpret them, which is really already theoretically in place before we even observed one of the objects, which has basically warped our interpretations ever since, and makes them as if they're differentiating. Oh, those are black holes, they're crazy. I know, they're just mind-bending. I know, they're freaking... Are you sure they're not just emitting in the X-ray spectrum? You know? And then maybe even beyond. And he just mentioned Hawking points. Maybe there's objects that are even more massive, that are like so infrequent in our observation that they are like stars in the cosmic microwave background, that we then call like Einstein or Hawking points. Or it's just remnants of the Big Bang. Fuck, I don't know. Anyone watching, I have an explanation for all distant redshifted galaxies. That's basically the figure 8. Light from distant galaxies, we think it travels in a straight line to get here, but maybe there's objects that are so massive that they bend and gravitationally lens and redshift / blue shift the light from all galaxies we see. Maybe there's one that is overwhelming everything we see and causing the light to travel in a figure 8 orbital, and basically being part of its electromagnetic field. The light in traveling in a figure 8 orbital, the summation of it all, the collective flows being the magnetic field of this object. And then the light, at some point after traveling any number of times in this figure 8 shape, happens to arrive at Earth at any angle and at an additive distance of redshift per distance because of the orbital motion. Because if light's traveling in a figure 8 orbital and the central object that it's orbiting is red shifting and blue shifting the light, the cumulative effect, because it would basically go out and then back in the same distance, the radial motion would cancel, so there'd be red shift and blue shift canceling. But because it's coming from one side of the orbit to the other side, each figure 8, one side to the other, it's always with a motion away. And so that produces a additive redshift per distance by gravity with no motion of the actual galaxy causing it, but rather gravity causing it, which is simple, and we don't need any new features like expansion of space or dark energy to explain the redshift. If we could just explain it with gravity, maybe it's a little less straightforward literally by being a figure 8 orbital, and so therefore it's a little harder for us to see straight away because of this bending going on. But that doesn't mean that that's not happening, because it would explain the redshift, which is, I've not seen any other actual tangible explanation for the redshift besides expansion of space. But the thing is, expansion of space makes no sense from a philosophical standpoint, and it just leads to new complexities like dark energy. Like, okay, we need expansion of space, well, now we need dark energy. What's next? You know, we just keep adding like new things to explain something. Oh, we don't understand this observation, so that means that there's, I don't know, what do we call it, a dark gravity. You know, just keep adding dark to some other term, and now we got this other dark magnetism. Whoa, dude, it doesn't make sense, but we know it's a new thing that like at some point when we explaining more with more doesn't help. It doesn't help. It gets us nowhere. It just confuses things, because we're literally attempting to explain more because we made a new observation, but then the way we do it is by just having a patch. Oh, this doesn't actually just fit right into the model, so let's just go ahead and throw this in there. So I guess space is expanding. Isn't that fucking crazy? It doesn't make any sense, but that's what's happening. What's that? You're saying it's not linear as we originally predicted. Something is causing the rate of space expansion to accelerate? Oh, you don't know what it is, but you have a name for it, you say. Dark energy? Oh, that's provocative. I like it. Good work.
Generations experienced. People think that they've seen 3 copies of Lego. Imagine that you had a Lego set made of plastic, one made of wood, one made of lead. The Lego would sort of be the same shape, but the weight of each set of Lego would be different. Now, is there a tungsten platinum set? Is there some other platinum set? Is there some Lego set beyond the 3 that we know about? I actually claim that we only have 2 generations of matter. Because what's really happening in my mind is that for something to be a true generation, it shouldn't just be a generation at low energy. It should retain the same properties as the others when you heat them up. So if you have 3 things that look the same when they're cold, but only 2 of them look the same once they're heated up, then you might have only 2 generations. Or maybe there's only one unique generation and there's 3 different versions of it and they all look the same when they're cold. So never heard anyone in my life say that. I don't know why, but I believe that that's a consequence of my theory, that there are only 2 generations, not 3, whereas everyone else would say we know that there are 3, maybe there are more, but there are limits on it from astrophysics. What are the other questions?
The number 3, why are there so many parameters? Why are there so many particles? There are some things that there is a grade that I would say is higher than an F minus, which I used to get a lot of in high school, such as, are neutrinos massless? He asked that question back in 1988. Now we know they're not massless. At least one of them has a mass. We know that surprisingly from astrophysical experiments, not unlike the ones that my colleagues and I do on the Simons Observatory, etc. Cosmic microwave background, baryon acoustic oscillations, etc.
Massless. Just the idea that something is massless is kind of ridiculous. It's already disproven because we can see stuff around us has mass. And so why would it function differently? Maybe it's just that we can't see that far in terms of like the difference between its mass and 0. And so we basically are like, that's 0. But it makes no sense to draw that conclusion. Of course it's not 0. Of course it's infinitesimal, but something of substance, because it's interacting with the rest of everything, meaning it's of substance. It exists, nothing massless. Does that even exist? Like at that point it doesn't exist, because mass is its substance in essence. Its existence.
People are asking, so we got a 50 krona, I don't know, I think that's about $7, I'm not sure. 50 kroner question. Actually, it's not a question, it's just how to pronounce et uft. So thank you very much from Norway for that. People are questioning, again, how do we fit and reconcile the need for something when there may not even be evidence of lack? In other words, is there a lacuna in physics when if the old one, as Einstein called God, hands us a piece of paper, and it says there are no singularities at the center of black holes, and there was no singularity in the early universe. Sir Roger's right again, or Sir Paul Steinhardt is right. There's no singularity. Would you give up GU?
Sorry, I don't think there is a singularity.
Okay, so singularities are not part of the motivation to unify gravity with the other higher energy force.
Well, this is the uncomfortable part. One of the problems is that we love Einstein a little too much. We sort of treat our great physicists as heroes, and then we make the mistake of taking the top of our pile, and they stop looking like the rest of us. I don't think that Newton and Einstein have the same sort of feel, even Dirac. I mean, weirdly, Maxwell, I think, did this unbelievable work, but I don't think that we live in terror of Maxwell. I don't know why that is. Maybe it's too far back. Weirdly, Newton, because of the calculus, everybody's in awe. I think that the great fear is that we're afraid to challenge.
Newton was just right. That's the truth. Everyone should be in awe. Dude was on it. People after him kept going as if he hadn't found it, but he found it. People in his time appreciated it and after, but then over time it kind of became taken for granted how universal his actual model was, and people lost like the touch with its like value, and because it's philosophical, it's natural philosophy. It's literally from a time when like science almost was like and yet it was more in touch with reality than science is, because it's not even philosophical anymore. Where is the thought? It's like, oh yeah, that's how it is. It's crazy. It's crazy. It just is how it is, and we see it and no thought, in a way, because we're accepting that it makes no sense.
Einstein. Most people who challenge Einstein do it because they don't. It's sort of like picking a fight with Khabib Nurmagomedov. If you were smarter, you wouldn't do it. So dumb people pick fights with like the most dangerous people.
Well, you
around.
remember that, yeah. I always compare it to like Dungeons and Dragons. I get these emails literally every day. I'm sure you get them too. And it's like, Professor Keating, Einstein was wrong. I can prove how. And if you help me, I will share my portion of the Nobel Prize with you. And I told it to Adam Rees, who won the 2011 Nobel Prize. And he said, yeah, how do you think I got this? I answered one of those emails. Someone's asking a young Weinstein. Let's say there was young Weinstein. Like I have.
I wanted to get to the previous.
Oh yeah, go finish that. Yeah, and then we'll get to.
I'll say that. Oh shit! What have I done? Oh no.
Log back in
Yeah,
and see if
I,
I can
I
solve
just
her
changed
problem.
something. Let's try that because I don't know if people can hear me out there.
I'm gonna pause and see where I was.
With like the most dangerous people
Well, you
around.
remember that? Yeah,
I accidentally went back on the clip, so I lost my place. So I had to find it, so I paused. And he was saying this, I thought I'd go back a little bit because it applies. And maybe let's just slow it down.
Afraid to challenge Einstein. Most people who challenge Einstein do it because they don't. It's sort of like picking a fight with Khabib Nurmagomedov. If you were smarter, you wouldn't do it. So dumb people pick fights with like the most dangerous people
well, you
around.
remember that? Yeah, I always compare it to like Dungeons and Dragons. I get these emails literally every day. I'm sure you get them too.
Dumb people. And then he starts now talking about dumb people, emailing him, including me, who's been ignored, who's got an actual argument of merit, of substance. And then I sit here. It's unfortunate, guys.
And it's like, Professor Keating, Einstein was wrong. I can prove how. And if you help me, I will share my portion of the Nobel Prize with you. And I told it to Adam Rees, who won the 2011 Nobel Prize. And he said, yeah, how do you think I got this? You know,
I'd like more details on these emails. Like, besides my own. I'd like to know, what are these ideas that you guys are just casually ignoring? Hello? Like, do you understand there's no model right now? There's 3 models. So there's a problem. And as he mentioned, if you guys are like the science educators, and like there's some like emails that are received all the time, you guys are getting all these ideas and you're not even like transmitting them, passing them along. There's got to be a better way, and not just throwing them away into the dustbins of the freaking ignored emails. Like, maybe not. I'm sure most of them are pretty missing. You know, just swing and a miss. But hey, some of them might be making contact, and some of them might be fucking smashing it. Just on point. Precision, high resolution. Just crushing it, but just dismissed offhandedly because they don't look like what's expected. That's why this isn't what I thought it would be, so it's wrong. Next. Glad I read the first 4 words of that. Really gave that some time and thought and consideration, and didn't. That's what happens. It's just what happens. And it happens to me. And when I got answers and it's happening to me, it's a problem. It's a problem, guys. But no, I'm fucking wrong. That's the thing.
I answered one of those emails. Someone's asking a young Weinstein. Let's say there was young Weinstein. Like I have.
I wanted to get to the previous
Oh
one.
yeah, go finish that. Yeah, and then we'll get to it.
So the point is that the singularities give me confidence that Einstein isn't the last word. That he's correct in his domain, but that he had this wonderful thing about or this aphorism about my equation is like a house,
which is nothing.
With 2 wings, one made of fine marble, the other made of cheap wood. And one side of it comes from curvature and geometry, and that was the marble side. And the other side was like, you just throw together whatever it is that creates something called the stress-energy tensor. And I always thought, okay, what does a contrarian do? The contrarian imagines that the problem is with the marble. And is there a body buried under the marble? Is Einstein? Are we so afraid to talk about Einstein's greatest achievement that we're giving him a kind of reverence that's holding us back? And so I think you both have to sort of go after Einstein, but it's going to be imperative that you restore him once you take him down from his pedestal. And none of us really want to do it because, quite frankly, we love him. I mean, we love him because he was everything we wanted to be. He was right about
false idol, guys. Stop fucking putting weight in his message because you love the messenger. Like,
the most important crazy things. He was decent. He was wise. You know.
Yeah.
So
no, it's true, but yeah, I mean, sometimes you have to kill your father, and you know, well, I don't know what do you do after that, but.
So you're going to take over my son's tutelage and tell him that. Great.
No, you will withdraw your tuition.
Singularities give me confidence to say I don't think that Einstein is the last word. Okay. And I don't think non-physicists and mathematicians, it's a little bit weird that we're so reverent for one of our own, where there's still people walking around who met him. And I think we haven't gotten over our Einstein issue, and we won't until he's made into an effective theory, and that's coming.
And even as I said, the great Nobel laureates and the others still suffer from imposter syndrome when they get confronted with even just seeing his signature gives them. Yeah, I mean, what else is it? But by the way, Eric, I mean, I also feel like, and you know from my book, Losing the Nobel Prize, that I feel like this medallion and even the recognition, the hero worship, is a form of idolatry. I feel like we worship people, and ironically, many of us profess to be agnostic or downright atheist. Lenny is a hardcore atheist.
No matter what, you pick a god. That's how it goes.
And yet, when we were talking, and this happened with Gad Sad, I had Gad Sad on my channel, who's a devout, practicing atheist. And he was quoting things, basically unknowingly, quoting from the Shema and from other canons of Judaism and Christianity. And so was Lenny. Lenny said, what's the most important thing? Because I ask all my guests, as I'm going to ask you in about 15, 20 minutes, you know, what would you put in your zava'ah, in your ethical will? Not your material will. I know most of that's coming to me when you're 120. But that good teal scratch, it's coming my way, baby. But I want to know what you put in your ethical will. Shelley refused to answer that question. Lash out. He would not answer that question. First time it's ever happened to me. It's kind of awkward, to be honest with you. But Barry answered that question, and Lenny answered it basically as justice, justice, you shall pursue. Now, these are these atheists. They're all Jewish. It happens to be there have been some Jews, and there have been many people believing Muslims. I've had on Marwa El-Dwini. I have to give her a shout out. She's your biggest fan. She wants you on her podcast even more than me, which she had on. So she's a devout Muslim. And these most of scientists would believe and profess to be atheists, and yet they worship Galileo. They worship. Eric has been knocked off the channel just as we were talking about God. Can you hear me, Eric? Are you there?
Can you hear me?
Yeah, I hear you.
Yeah, I'm here.
Okay, so what do you make of this hero worship? Is it hero worship? Like, we want to feel like there are people that are these super ninjas of the brain, and that, like Jack Nicholson said, you want me on that wall. You need me on that. We need them. What do you think?
I don't know. I mean, I feel like I've met my heroes and they survived.
And you survived.
You know, I used to hang out with this guy, Isidore Singer, Isaac Bashevis Singer's cousin at MIT, and you don't find people at that level of intelligence in everyday life. It's true. It's real. You know. Every week you have lunch with the same person. I weirdly sort of don't have this fear of hero worship. My feeling is you don't know what the human mind is capable of until you get into a small number of areas that prove, you know, I mean, look, Eddie Van Halen and Art Tatum prove it as well as Paul Dirac and Albert Einstein.
Yeah.
But there are just certain things the mind can do that nobody's prepared for. And when you met somebody who's touched the cosmos in that way, they are altered.
Yeah,
you know?
And yet they put their pants on, you know, one leg at a time, right? Eric, your microphone is a little scratchy. Can you, is there anything you could do to it? People are saying how slim you're looking. Maybe that's causing it. I'll use this option to remind people to take out their fingers, stretch your digits regularly, push the subscribe button on this channel so we can grow and continue to get guests like Ed Whitten, hopefully someday, another EW. And I'm going to ask Drew's question. I think it's a fascinating question. What area of STEM is most ripe for disruption or paradigm shifts? In other words, I'm going to ask that in terms of where would he advise his children to go into, and my children to go into, and what field of science is most ripe for disruption. Eric, can you hear me?
I can. Can you hear me?
Yeah, it's very scratchy. You want to use your phone? People are saying to use your phone. Maybe let's try that. Do you have your phone nearby?
I do. Let me see what his battery situation. Oh, 3%. Well done, Eric.
These theorists. Are you on your phone, by the way? Where are you on now? Because we don't see your lovely visage.
Is that right?
What's that? I hear you great, but I don't see you at all. There you are.
Okay.
It's a little scratchy still.
Yeah,
But
I think that the problem is that don't send your kids into STEM until Brian and I get to the National Academy of Sciences and turn over a few people and shake money out of their pockets into the coffers to pay for young people to actually have careers with stability and freedom. It's also incredibly important that we get some of the transparency out of the field because you need the freedom to think crazy thoughts when you're doing safe science. And I personally think that our desire to not waste taxpayer money is wasting taxpayer money. Yeah. What you need to do is to give the money to people who are dangerous, people who are original, let them figure out who they need to fund, make sure that it's not such a cutthroat environment, and let's get on with it and get back to being Americans. It is the greatest scientific country in the world, Brian.
So I want to conclude with a couple things that are on my mind. One is very provocative, which is that I was talking to Barry Barish, winner of the 2017 Nobel Prize for Detection of Gravitational Waves, using LIGO. Very wonderful man. He was working on a project called the Superconducting Supercollider, and they had been working on that for many years, and then it got canceled in 1993. Congress canceled it. I make the statement that that's a good thing. And in fact, perhaps he wouldn't have won the Nobel Prize, and maybe LIGO would never have succeeded because he was the decisive person, along with Ray Weiss, who will be on the podcast too. Another reason to subscribe. He's coming on the podcast soon. These are guys who are getting up there. I'm trying to get women, by the way, and they just won't come on the show. I don't know why. Well, I know why. I asked Donna Strickland, who is a hero of mine.
She's the Gen 11.
I had John Lem. I'm saying Nobel women. There aren't many, but I'm trying my best to have them on because I really want to feature them because I have a lot to learn from them, and we both have daughters, and we want to be inspired, and our sons too. But anyway, she just doesn't do podcasts, she said, and I'm trying to get a hold of Andrea Ghez, who's a colleague at UCLA, but it's been tough. Anyway, I want to get back to this. SSC cancellation. My controversial opinion is it was good because Europe ended up doing it. It was built to detect one thing, which is the Higgs boson, effectively. I mean, people can argue with me. Cost $20 billion when you actually add up the money. And by the way, whenever a physicist tells you something is going to cost X billion dollars, always double it because to operate it costs as much as to build it over 10 years. It costs 10% per year to operate of the construction cost. That's operations rule of thumb.
Dude, 20 billion. I don't even know what he's talking about. Just the waste, dude. The waste.
Number 101. So, if he had stayed on the superconducting supercollider, we would have spent 20, maybe $30 billion. We would have detected the same thing, maybe a little bit earlier, maybe not, and he wouldn't have worked on LIGO, and LIGO wouldn't have succeeded. So it's a good thing that SSC got canceled. What do you say?
Wow.
Okay, tell me where I'm wrong.
Well, first of all, we pissed off Congress, and we lied to Congress about a science shortage. And if you take, for example, our mutual friend Rabbi Walpe, his cousin Howard Walpe held hearings. And the basic question was, why did you, the National Science Foundation, and you, the National Academy of Sciences, lie to us? You had a special deal with us, and you stupid effing morons, in fact, concocted a scheme to, for some reason that we can't figure out, to do shitty science inside the National Science Foundation, National Academy of Science. You bamboozled us. You got us to pass the Immigration Act of 1990, and then we find out that, in fact, this is an incompetent demographic study because it didn't take demand in the labor market. This is the same time that they also said, what are you doing buying art for the SSC at these prices? And quite honestly, I'm incredibly disappointed with the senior leadership of the physics community, for one, not understanding the political sensibilities in Washington, but also not leveling with them, which is, you take our toys away from us.
Just in society, you know, it's a fucking real investment. Someone's casually like, yeah, that's worth it.
You're going to screw yourself over. In effect, we have intellectual SEAL Team 6 at your disposal. And what we like to do is to train and work out. We work on physics, but we're available to you guys. And this is an advanced technological nation that brought forth atomic weaponry. You need your best and brightest to go into these fields and to make sure that you're current. Given, for example, that the World Wide Web, for example, came out of CERN. There is no question in my mind that if you try to do a cost-benefit analysis on why are we spending so much money to look for particles for these people, you're getting it wrong. We are at almost the end of perhaps the greatest story in the history of the world, and we're acting like a bunch of putzes. And $20 billion is not that much for the people who helped end World War II with two monstrous weapons dropped on our now ally Japan, which is incredibly...
It is when it's a waste of fucking money. Like, goddamn, guys. Oh, we're probing the depths of reality. Or your model's all fucking wrong and you're just, just redlining. Just what's next, and 30 billion and 100 billion and 200 billion and what? We found some more particles that you got to name. Reinforce that there's more particles and it's even more complex somehow. Or maybe we could pause and think about it. Save some money. Think about it. Oh, don't worry, I already did it. Already done. Check. You can go ahead and just listen here. And then we can do some not so expensive experiments. You know, not 20 billion. Like, it's a waste. It's not like, oh, science needs it. Guys, people are starving. Like, it's a waste. It's like wasting all the campaign money. Oh, we raised all these funds to. All these people are like, oh, I need this person to be president, so I'll give them my cash. And then they're like, let's pay for some ads. We'll put trash in all the fields. Don't worry, they'll say Trump, Biden, across the street from each other. So now we got signs there, we got signs there. We'll get signs down in the next block, and we'll just have a row of fucking signs that will become trash. And this is definitely like a good idea, right? The same premise, fucking waste. How about let's fucking feed it in to where it actually needs it, before, you know, and get a healthy, functional system. Which again applies to me as I'm like having serious health issues, I wonder.
Horrific for all those who died, but it was also the decisive end to World War II. Your communications devices, the semiconductors in your phone, almost all of
And was it? Don't trust this fucking system. Don't trust this shit they say. It's not so simple. There are layers and layers and layers of shit going on. And
this comes from theoretical physics. As much as I really often dislike dealing with theoretical physicists, but it's like, I'm sure I would be SEAL Team 6. They'd probably think I was a pussy. On the other hand, do I want SEAL Team 6 to be well-funded and to be there whenever I need them? Absolutely. Well, this is what it takes to get the world's smartest engineers, the world's best mathematicians, the world.
why, dude, why? When is enough enough? See, all is one. What a waste. Why are we wasting all this money to go kill people across the world? Literally creating scarcity. And I'm like, oh, stuff sucks here. Let's kill each other now. It's just like feeding into it.
Top physicists and minds working together.
All is one, guys. Until we realize that and stop having our little borders, our little dividing lines, which cage us off and make us a closed system and cause entropy to increase because they're closed systems. Until we have an open society where all is one, you know, we stop drawing these. Like SEAL Team 6, like, no, there's no reason for it. Oh, there's reason because blah, no, waste. Stop, guys. Anything that's pointless, like, why the fuck is there an army? Why is there a military? Outdated. Unless there's some kind of, like, cosmic threat that comes along and we all get unified together. It's always this the holographic invasion, alien invasion to unite us. Never know. They talk about that shit. I think if that happened, where there was a holographic invasion, or where they staged it, it would only be a sign of, like, it hasn't happened yet and there's a real shit hitting the fan moment coming. Maybe it's not an invasion, it's just the reality hits where they're like, dudes, you know you're God, right? And we know we're God, so we're just here to help. Hello. Nice to meet you all, and alright then, let's carry on.
to be available to our government and our country when we need it, and to make progress and potentially, let me turn it on you guys. You guys brought us into the valley of...
No boundaries in our country. I mean, I put boundaries. I say we, especially when it's like, I don't agree with the idea. I'm like, they say the Big Bang happened. Even though it's me saying it, because all is one. So, me, all is one. Even though. It's not good. It's just like learning. Oh yeah, I did it again. Now I gotta observe it and see it and reflect on it. How I say we in this circumstance and they in another.
Of death. And the only people who are going to get us out of the valley of death after the atomic weapons of World War II and then the fusion devices that followed in the early 50s, the only people who are going to get us off the planet are physicists. Elon started as a physicist, but those rocket engines aren't good enough to get us diversity beyond the solar system. We need a huge number of different planets to experiment with so that we don't all go up in one fell swoop on the one that we have. Right. So the short answer is we pissed off the government. We changed our agreement with them catastrophically. It was part of two separate sets of hearings. And quite frankly, I think it's the mismanagement of the physics community's legacy by senior physicists, and it was a horrific thing to lose.
So I want to give some news to folks that we are going to be...
Pissed off the government, as if they're the authorities. Did you realize that you guys get power from the people? So it's okay to piss off the government. Like, it's okay. What's wrong with that? Sometimes it's deserved. Sometimes the criticism is warranted. And sorry that it's offensive, government. But you're not real anyway. Like me. I'm real. So if I'm talking about the government, who's not even real, and people are like, grr, grr, how dare you? Just because we made it up. Okay.
working together on a project for revitalization and in concert, experiment, and theory working together. Eric and I have plans for this. Stay tuned for that. Again, please subscribe to Eric's channel, the Portal Clips, and listen to episodes. I believe I will be on an episode in the not too distant future before the universe doubles in size. We've recorded an episode. Someday that will be available, and I want to thank Eric for that. I want to close with a couple more questions from the audience. We have one from Russia with love, and that, if I can find it.
By the way, just to come back to at the very end, let's come back to the question about what to do with a guest who says something that you don't feel comfortable.
Well, let's do that now because time is running out. The day is short. I want to know. I'm dealing with guests, and this week was this kind of up and down roller coaster for me. I had, just being honest, I had wonderful guests that were really edgy, interesting, controversial, but don't even care about their legacy. I had other guests on this week that are very considerate of how their reputation is handled and not wanting to be too controversial, even when I know that they have controversial opinions. And I'm not like here to be Jerry Springer of physics, but the bottom line is I think that they sometimes will manage an image in a way that is contrary to what is best for at least my audience. Now maybe they don't care about my audience, and why should they? We lost Eric, but we haven't lost me. I will keep going. So the existential crisis that I faced is whether or not to involve Eric. Can you hear me?
Yes, Brian. Sorry, you said you had guests on. You had a tough week, and then I couldn't hear any more.
Yeah, no, just having guests that are generous with and open and willing to be vulnerable. And I think that those are the most interesting people, and they help demystify the Einstein syndrome that we were both decrying. And when I'm dealing with that, I'm like in real time. First of all, I want to know, Eric, when you're interviewing somebody, do you have a metric that you're using, like I'm doing a good job at this interview or I'm doing a bad job? I have one or two, but I want to hear, what are your tips as podcasters, especially with really intellectual guests that you get on, excluding me?
I haven't solved this puzzle. I talk over people too much. I'm too aggressive. Sometimes I don't want to embarrass somebody and I maybe shortchange the intellectual. Sometimes I want to do the intellectual right and I feel like I didn't take care of the person properly. There's a huge number of competing pressures. And I think people see us failing at one thing or the other. They don't realize that it's not because we didn't consider, maybe I should shut up, maybe I should let people finish. It's sort of like, wow, if I don't say something, then this is going to go on for a 20-minute riff and we're going to lose the audience. Okay, so in this situation, I had a little bit of this situation with Garrett Lisi. I like Garrett and I care about him. I think he's very imaginative. And I think he brought a lot of good ideas into the world, even though I think his theory is wrong. I don't make a secret of saying that his theory is wrong, but it's clear that I hold him in high regard as a human being, that he's generative, that he's original, that he's trying all sorts of positive things. When I interviewed him, I guess he had decided that he had moved from E8 to an infinite dimensional version of his own theory, and that this was the solution to the problem. And it was a significant enough pivot that I didn't know how to address it entirely. Because I sort of felt like you should at least acknowledge that the other thing didn't work, and maybe this pivot works. But one of the problems in startups is if you keep pivoting, then the question was there something there at all? And I think that Gary had a really interesting, good idea that doesn't work. In the case of, and in Roger's case, I interacted with him, and there were some places where I feel like we didn't have a satisfying intellectual connection. So I think that that's normal. And I think that when you love people and your friends, like it's possible that you and I could talk about geometric unity, and you would say, wasn't that a minus sign? I'll say, no, is it? Oh, really? Did 35 years of work just go out the window? It's a nightmare, and it's funny. It's hysterically funny that we live our lives like this. But the thing is, what else can you do? I mean, at least we're trying. At least as a theoretical physicist or mathematician looking at this stuff, you're trying. And if you fail, all that can be said is nobody else figured it out either.
Yeah, you failed daring greatly, like.
As long as we ignore people who figured it out, I guess, yeah, no one else figured it out.
Teddy Roosevelt said. So when I'm doing something, I want to get your opinion about. If I'm interviewing you, or I mean, you and I are good friends, but if I'm interviewing a hostile witness, and I hear them say something like, "That's a good question," I kind of think that is a good question. Whereas I hear them say, "Well, as I said before," then I realize, oh, I'm not doing so great. Or similarly, when somebody says, like, they just stop and think, and I let them try to like hang themselves, like not hang themselves, but I let the silence do the work. And I wondered, like, do you have this loop in your head to be a good interviewer? We're not trained in this. We're doing the best we can.
See, I try to embrace things like, you said imposter syndrome. I've listed my occupation as imposter on numerous occasions. I talk all the time about the fact that I'm not a physicist, and here I am opining on these shows and blah, blah, blah. In all of these circumstances, you have to sort of play with it and make fun of it. Like, I'll be honest, when you said Lenny Susskind is obviously incredibly successful, I had a moment where I said, is he? I mean, I understand that he's very highly regarded and he's contributed many theories, but does it cash out properly? If I were to list Kumran Vafa, if I were to list Ed Whitney.
Who's going to be a guest next week? Kumran Vafa. Yeah, that's a good question. I have a question for you. I'm sorry to interrupt, but time is short, and I do want to get to a few things for you. And maybe we'll do this again next week. But the point, Eric, is I say this, another provocative thing, which you'll probably shoot me down for, but I say it wouldn't have made a difference if electroweak unification was discovered in 1962, as it was by Shelley Glashow and collaborators, or if it was discovered in 1982. But it would have made a big difference if the transistor wasn't discovered in 1956 and instead was discovered in 1976. So I think that there is sort of a fungibility in some sense of theory. In other words, theory is going to be discovered, but experimental or inventions, which is what Alfred Nobel wanted to recognize. I mean, what do you say about that? That there's sort of this time value of money, and that we really should invest it purely in experimental physics and not any in theoretical science. I mean, nobody looked at the quantum mechanical laws of Schrodinger and said, let's build a transistor. These are some guys fritzing around in a garage, and you look at the original transistor, it's chewing gum, it's a coat hanger, it's a crystal, it's pretty wacky stuff. And nobody looked at the Schrodinger equation to solve it.
Boy, do I have a different impression of this. I mean, my life is so determined in part by the synthesis.
Theoretical physics doesn't cost much. Especially when it's people like me who are eating the cost by just doing it because they are interested. And there's something to be said to that, where theoretical physics really doesn't seem like it should have its, like, funding in the same way as experimental. But neither should experimental when it's just frivolously wasted. So there's always that back and forth thing. Like if we're arguing for a collider because we want to do experimental physics based on a theory that's not even sound. Like, they knew there were 3 theories when they made the colliders. They knew. They're like, oh, these can merge into one. All we need to do is spend billions of dollars. We'll just literally force things together and we'll see something because we're just smashing shit. Look at how hard we smash those things together. Like, that's literally, it's demonstrable of the method of analysis to just smash shit together and see what happens. But doing it expensively, because, we're pushing our boundaries. We already did the cheap stuff. But it's not fruitful. I mean, it is to a degree in that we get those observations. And maybe they were essential in the long term that they happened, and we'll reap the benefits in the long term of the investment somewhere down the line. But, like, really to see another particle, not really worth it when sooner or later it comes to light that there's infinite particles, infinite masses, the endless cascading array. And if we start naming them, like, what's the point? What's the point? It's just how we see a system relative to us. But really, well, there's no point. At some point, we just say, oh, it's infinite. Oh, it's infinite. Oh, it is infinite. oh, oh. And then, like, oh, those things don't matter anymore because they're just one part of an infinite spectrum. So, like, they lose their significance. They're no longer fundamental particles. They're just particles that we happen to see at that angle because that's our relative mass ratio, and that's just another way of seeing every other particle. It gives it more, it sheds more light on it, but it's not like it's fundamental.
That it occurred by the mid-70s. And if it weren't for Jim Simons and C.N. Yang at the State University of New York at Stony Brook figuring this out, my life would be completely different. I think that, so many things hinged on the fact that the Glasgow-Weinberg-Salam model, with, speaking of it, hooked, showing that we know my life would be completely.
That's a good question. What if the mathematics to solve the problems of physics have not been invented, discovered yet? Discovered. Maybe.
Completely different. I think that, so many things hinged on the fact that the Glasgow-Weinberg-Salam model, with, speaking of it, hooked, showing the renormalizability of these gauge theories and the way in which all of this stuff conspired, is incredibly important for allowing other fields to progress, in particular differential geometry and topology in this beautiful renaissance. So I think it actually was super important that this stuff should have been discovered earlier. It would have been nicer if when Yang and Mills, was it 1954, 53, something like that, came out with their theory that they had understood it to be geometric. I really think it's a tragedy that we don't have C.N. Yang on our lips. Whenever I hear people say that Steven Weinberger, Ed Witten is the world's greatest living theoretical physicist, I always say, I'm waiting for the day when another name is added to that, and C.N. Yang is my favorite.
I'm going to try to get him on the show.
Godspeed. But look, in part, I think it actually really does matter.
Right here, motherfuckers. Oh, is he cocky? Oh, he's so cocky. He must be wrong because he's cocky. See, like I was saying, how people judge the message because they love Einstein. They judge my message. And I mean, I'm a little not so lovable. Feel like, what the fuck, man? This dude is crazy. So the shit he's saying's crazy too.
The problem is that it's a story to which almost no one is paying attention. And if we're going to get off this planet, we are going to need a fundamental theory. You're going to want those theorists, in the...
Yeah, and we're not just going to fucking force it. That's the problem with, like, trying to go to Mars. We don't even understand physics and we're trying to go to Mars? What a waste. With fucking rockets, dude. Gas? Really? That's our energy. That's how you're going to get to Mars. Maybe we need a new fuel source before we can, like, really realistically talk about, plan, discuss, and successfully make it to some other place. Because without that shit, using just burning fuel, I mean, it's archaic. It's outdated. It's just an old system. And it's force fitting again. Just forcing it. Force. We'll just burn it. We'll burn as much as we need to and get there. As long as we're burning the shit out of the shit, we'll burn a lot of it and we'll fucking go. Like, there's definitely a way to tap into the ether and take particles that are dispersed and focus them together to create larger particles that can then be functionally become a fuel source, so that you're on the spot creating energy out of nothing, out of the ether, because we're focusing the particles together to create energy on the fly. If we can do that, then maybe we can travel. But when we're freaking carrying this heavy ass tank, fucking crashing 90% of the time or some shit, it's not reliable. Maybe we should wait, figure something else out, stop spending the fucking money. Spend. Maybe this'll do it. Maybe this'll do it. Oh, did the system collapse around us? Shit, that's so applicable to life. It's so applicable to life. And a lesson that I still am not applying to life, which sucks.
Jack Nicholson's, you're going to want this theorist on that wall.
Actually, the wall is at Stony Brook, and you and I are going to go in with a chisel one night and chisel some equations on the wall. Okay, we have a few minutes left. Any other questions? I want to scan quickly through, make sure people got their money's worth. But while I'm doing that, Eric, I want to ask you a question that I asked. This is from Allison Walker. Quick one. Thanks. It's written on top of a purple heart. Okay, I don't know what that means, but Allison is a good friend of the show. Thank you. I want to know if you subscribe to this notion of the ethical will. And I asked this of all my guests. I asked this of Jim Simons to Jan Levin to almost anybody that's come on the podcast. And I want to know, in your opinion, if you were to leave a legacy, not of material goods, but an ethical will, a will of wisdom, a will of experience based on your experience, that would be not only for your biological children and grandchildren, may there be many, but also for your ideological children, of which there are already. You realize you make a huge impact on the world, Eric, and what you say people listen to and pay to hear, and I get it for free, and I should reimburse you someday. I'll pay you that 3 bitcoins that I promised you 20 years ago. But anyway, what would you leave in your ethical will? And then we'll finish up with a question from our friend Tyler.
I mean, I think what I'd leave is, look, the only thing that I've ever done in my life that has the ability, even potentially, to compete for the attention of people 1,000 years from now would be geometric unity. And it's quite possible that it's just wrong. I don't think it is. I'm betting heavily on it. That would probably be the first thing. And what that thing is it's about hope. It's about all sorts of crazy human motivations. It was an incredibly self-destructive undertaking. And I worry about communicating it to my son, which is, do I want to tell you to try to do something at all costs?
Incredibly self-destructive undertaking. Well put. So you're welcome, motherfuckers. Oh, this hate, man. And I put so much into it. People don't know. It's like you take all the energy that you have, and then you squeeze it out and put it into this other thing, and then you try to live. Self-destructive.
Against all odds, money's no object. Health is no object. I mean, my guess is that I was probably overweight for a large number of years, in part because I'd stopped thinking of myself as a member of this planet, which is probably incredibly unhealthy and delusional.
Wait, you intentionally? You feel like that was intentional? I mean, for me, I'm addicted to food. I eat too much because...
No, of course, but my point is that I sort of checked out. And, yeah. I mean, when I talk about this twin nuclei problem, I'm not kidding around. I really do believe we're all wearing face masks potentially because of something that might have come out of the Wuhan Institute of Virology. And the thing that gives me the most confidence is just how certain I'm not supposed to say that YouTube and the federal government is, So I don't know whether we're going to have a problem with nuclear weapons. I don't know whether we're going to have a problem with these viruses, but we have to get out of here because we've outgrown this planet. We're too powerful and we're not smart enough. Our politics is a mess. And we've got to spread out because we can't have one correlated experiment. So that's the core of my ethical will is that. Now, I speak a lot on a lot of different programs. And one of the things that I feel very confident of is that if my children ever choose to pay attention to me again, there will be a corpus of audio and video that indicate what did I think? What did I think about politics? What did I think about decency? What did I think about, how we treated homosexuals years ago when we wouldn't allow them to marry? I think I've opined on so many things that if were I to die this instant, there would be a huge record of my thinking.
And I think, too, as I've told you, what if you stumbled upon something from the shtetls of Eastern Europe and it said, great grandma Nechama Weinstein, and you found this book and they said it's going to be 100 Bitcoin, you'll pay it. And so I want you to think about your children's children and think about putting something in writing because we have books from Galileo. We have books from Einstein.
You're lying. You've been trying to get me to write a book for ages, and now you're pressuring me and you're negging me on international television.
I'm just saying, people are out there. Okay, people are asking, what is Lex Friedman like, and what is his uniqueness in the role of the podcasting world? And then we
Lex
have one
Friedman
comment.
Is brilliant, gorgeous, and ladies, he's single.
And Tyler is asking a question. I'm trying to find Tyler Goldstein. Goldstein has a question, and I want to get to that. Allison, I don't know.
Want to go rapid fire?
Let's do rapid fire. Yeah, okay. Vulnerability is kind of, we realize it's space-time. Let me see here.
Take the energy up, Brian.
What's that?
Take the energy up.
Okay. Okay, what do you think about Gödel? Gödel's incompleteness theorem.
I never wear them. No, sorry. I think that it's fabulously interesting, but I think that we tend to do it too much as a gee whiz. I'm sure that there's a formal way of saying it that sounds more like there's certain things that are true for good reasons, there's certain other things that happen to be true, but they don't have a good reason, and that means you can't necessarily prove that they're true inside of the system. I would love to hear somebody say it that way. I've never heard it properly done by a logician, so it has too much of a gee whiz thing.
All right, Tyler Goldstein is asking, Eric, if I remember correctly, I think you said on a podcast, the next scientific dynamos may be religious people. Do you think these people would have to find unorthodox paths presenting their work outside of academia?
Ish. The problem is that right now we're having a huge problem with academics becoming too self-destructive. In a weird way, you pay a cost for being religious, that you often believe something without on faith. There are religious scientists who are able to take their faith and their science and separate them so that they do good scientific work, but they use their convictions to potentially...
It's interesting. Maybe religious people. I'm religious ultimately because, I say all is one, God is everything. My message is pretty religious. But I'm not religious in that I wasn't, intentionally religious. It's just I saw the truth. And so it's religious. So the next scientific dynamos is gonna be religious because it's essentially the truth of that God is all is just part of it. And we'll have to find unorthodox paths to present their work outside of academia. Oh, hell yeah. You think science is going to be the path? It is such a narrow and restricted path of travel that it's not going through those paths. It's going to find a more open path for the information to be transmitted through, which is unorthodox, like podcasts, like YouTube and all these things. Just enough to get the idea to like break the surface, and then be out there if it's right. If there's an idea strong enough. My idea. Sorry, not to call it mine. I'm taking claim. I was just fucking like spoon fed like a child. Here you go, little one. And then I'm all like, I've done it. That's the truth.
Martyr themselves and put themselves in low
Spoon fed like a freaking, just like a bird eating the vomit.
probability of success situations. That's what that was a reference to, and I happen to know some biologists who don't agree with Darwinian theory, but if there were problems in the neo-Darwinian synthesis, let's say, you might find that the people like Richard Dawkins would be wanting to say there are no problems in that synthesis, and you might be dependent on somebody, even assuming there's no God and everything is completely materialistic. The challenge might have to come from a religious person who would destroy their career going up against neo-Darwinian ideas. But then that person might actually point out, that thing you said about random mutations, they can't possibly be the engine, the principal engine of evolution, because the search space doesn't conform even over long periods of time with many bacteria exploring genetic variants of certain primary sequences. So that kind of self-destructive energy comes from religions. One of the reasons why religions have been very difficult to get rid of by atheists, because in fact, when people have that kind of faith and conviction, they start thinking beyond themselves, and that's a very potent force.
Is there anyone you're afraid to debate?
Sure.
Care to name them? Care to name her?
What? Care to name her? Let me think.
Nah.
Well, look, there's one person who absolutely terrifies me intellectually, and that's Ed Whitman.
All right, we're going to try to arrange that, as you know. That's my white whale, my white Witten whale. Is there any position in physics that you think is being promoted purely for hype? In other words, wormholes, time wars, the simulation hypothesis. I mean, these are all things that I think of as hype. What do you think is the biggest hype?
Well, I think the whole gee-whizification of things that are real, like Boltzmann brains, the multiverse, It's like we're always interested in time travel going backwards and wormholes to parallel universes. And you've got to know when to quit and how to do science fiction right. I feel like what we've done is we've taken a small number of topics with maximum sex appeal, we've sexed them up, and we've forgotten how many gorgeous, beautiful ideas. I've been I'll be honest, I've been talking about this for a while, and then I saw Sean Carroll do a series called The Biggest Ideas in the Universe. Now, Sean and I have sort of a weird relationship. We're cordial when we meet each other, but there has been some tension in it. And I wonder whether he'd actually heard me on programs like Rogan talking about the Hopf vibration and things like that, saying, why is it that we're not extolling all the cool things that we do? Why do we keep hitting these same topics? Because I think he had hit the multiverse, the Boltzmann brains, that kind of stuff pretty hard. To be generous to Sean, if I can, I thought he did a beautiful job over a very large number of very difficult topics, some of which I had myself been experimenting with talking about. So I think we need to stimulate some of our science communicators to showing more of what it is that we actually do, because it's so effing cool that it's crazy that we keep it locked away while we bullshit about things that are of marginal importance.
Okay, rapid fire questions. James Thompson, is the universe expanding or are atoms shrinking? Yes or no?
Don't love the question.
Should my kids go to college or try to find something outside the college university system?
I think we should try to send our children to graduate school and skip college. We should try to find lambda school-like opportunities to cut down the expense. And we should partition the subjects that are super serious as a heart attack subjects, and get them away from the subjects in which a penchant for bullshitting and fashion tends to take over the subject. We do some incredibly important, difficult things at universities, and we do a lot of things that shouldn't be done at universities, and it's time to divorce them one from the other. So I think it would probably be good to start doing away with the current college model and try to figure out what's next.
Do you think that Trump will leave office?
I do.
Do you think that he has a secret file on the incoming occupant of the Oval Office?
I don't even care. I think that the key problem, my guess as to what's going on is that the Democratic forces and the establishment forces have oversold just how little fraud there is, and the Republican and Trump-like forces have oversold how much there is. And so the weird part about it is that people are also kind of lying about the truth, and that's causing us to get very confused. It's somewhat akin to the question of, did HIV cause AIDS? They jumped the gun on it, but it was also true. So if you were using a jump the gun detector, you decided that was BS. On the other hand, if you used an underlying thing, you would say, well, that wasn't originally true, but it turned out to be true. My guess is that there was way too much pressure to put Biden in office, but that Biden actually did win the election, and that's going to be very difficult for a lot of the Trump supporters.
You think he's going to come back in 2024?
well, as a 78-year-old guy, I think he's doing a lot of damage to himself. If Trump walks out of the Oval Office babbling incoherently about so unfair, without putting up a serious conspiracy theory. I mean, at this point, I want to see a serious conspiracy theory or concede the election. What is your conspiracy? If you have the data, if you have the allegations, I want to know them in terms that I can really understand. And I understand it might take you 5 years. We might find out the deep state through the election 5 years from now. We don't have 5 years to wait. So if you don't have it now, and if you don't have it for the courts, you're going to have to leave office.
Would you rather have a Nobel Prize or be president for 2 terms, guaranteed?
I would definitely not want to be the president of the United States.
Do you think it's dangerous if a Jew would become president? Would that be a good thing for the world, a bad thing for the world? What do you think?
I think it depends on the Jew.
Okay. Let's see here. Someone wants to hear a serenade on the way out. We'll give that in a minute. If you had a time capsule that you knew would last 1 billion years, like a monolith in 2001: A Space Odyssey, I may have asked you this, but I may not have. What would you put on that monolith, for some species in the future to discover when they're ready to discover it?
There's a wall that we are going to visit in the State University of Stony Brook, State University of New York at Stony Brook.
Where I was born.
The whole point is to get that wall right. There's a bunch of stuff on that wall that shouldn't be on it, so we have to deface the wall to remove the things that are extraneous. We have to improve the things that aren't in their proper form. But that wall is an unbelievable mecca. And all you young kids, if you want to know what that monolith should look like, go to the Simon Center for Physics and Geometry and take a look at that gorgeous Indiana limestone and the beauty of what is written into that, and make your assignment for your life that you will understand what is carved onto that wall by the time you hit your 30s.
Would you rather shrink to the size of a DNA molecule or be able to visit the interior of a black hole inside the event horizon?
I was just hoping to get some sleep this week.
Well, your Tuesday's canceled.
Okay. Neither.
Okay, neither one. Okay.
I'm a mesoscale kind of a guy.
Would you rather go back in time 500 years or forward in time 500 years?
There's a particular weekend I would like to visit during my junior year of high school, but we don't get do-overs.
All right. Okay, Eric. Someone's asking, will you serenade us out something mind-blowingly amazing from the world of geometric unity underneath that Yiddish cup of hair? Will you serenade us on the guitar as you take us out? Maybe a Shalom Aleichem or something like that for the evening that's about to approach. That's awesome. Thank you so much, Eric. We'll do this again. Maybe we'll make it regular. I want to thank the audience, all you super chatters, regular chatters. Please subscribe to Eric's channel on iTunes.
No, Brian's channel.
All right, fine. If you must, please subscribe.
All right. They didn't talk that much about alternative theories, but yeah. I wanted them to talk only about theory of everything. Anyway, so that's my reaction. I'm thinking I might speed up the portions where I'm just watching and just provide a link to this video, which I'm going to do anyway, but rather than having it all, even just like speed it up, cut it out, and get like 20 minutes into like a few seconds here and there, at least just enough to like make it not quite so long, because it's probably gonna be about over 2 hours, I think, or about 2 hours. So anyway, I'm just gonna call it so. Later. Thanks for watching, guys.